here we look at how to auto-run files. So the question is, you have now written your software, and each time you want to start up the ESP, be it on a power supply, be it on a power bank, be it on a computer, it should boot into your program. It should run your program. And we go through this step by step. So the main message here is you put it on it. It has to have the name main, or we have to call it from main, but we go through it step by step. So let's get started. So what do? We look first at a piece of software which we can start, and what I choose is here in the tutorial display. We have one example here. It's basically a piece of code that runs and shows what we read over the analog digital conversion on the display. So I've downloaded this file adc2disp already, and what I'm going to do is I put this on the chip, and we are going to let this run from our command line, from the Python prompt, and then we try to get this into AutoRun. So let's get started here. We have the IDE, and now I connect our microcontroller. Now we have to look, it's COM4, and what we see here, there is only one file, and this is already called boot.py, and here what you see, all the things are commented out. So this is the first file that's called when the device is booted. So we could write it in here, but we should not, because this is mainly if you want to do system stuff, put it in here. So what we do now, just to try it out, we go here, and I have prepared this in AutoRun. So we need this file, which we just said, adc2disp, and I put it on the device. And if you look into it, we see we also need a library, SSD1306, which is the display library. And so I put this display library on it as well. And if we have this, what I can do now, I can just go into this one and run it. And so what we see now, if we look on the display and if you look on the screen, this is running, and I can turn the knob here. And if I turn the knob, we see things are changing. So the value is changing on the screen as well as on the display. But what happens now, if I unplug it, do this here, and I plug it in again, nothing happens. It doesn't start again. Now let's connect again and see what's there. So what we see, if we connect, I close those two just because I want to see what's on the chip. So I've got it here, and I have to connect now to COM4. Let's see. It seems it's not working, so let's reboot here. Okay, now we got it. Sometimes it gets stuck with the serial connection, so that's why I rebooted it. So what we see, the program I put on is still on there, and I can run it like here. So what we see, it's still running and it's working. So, and I can stop it here again and run it again. So the first thing I could do, I could just rename this program to the name main.py, and I do that. So once this is renamed, and we can see it here, now if I restart it, and we can try that, and I can restart it here on the reset button, that's the lower one. So what happens, we see here, it goes straight into the program, and I still have it here. So this is what we see. It works. So what happens now if I unplug it, and I've got a power bank here, So I plug it into the power bank. So obviously we don't see anything on the computer because it's not connected to the computer, but I plug it into the power bank and it runs. So it's now completely standalone, and I zoom a bit out. So what we see, it's standalone. There is no other cable attached. So we see it here. It is sort of running by itself. And this is sort of the first step. So if we call something main.py, it runs automatically. Now we have one problem. If we connect it back to the computer, let's do that. As you see, it's running, but now here we are not connected. And if I try with the IDE to connect, it's COM4, something strange happens. So I get this, oh, burn firmware. And this is because it cannot connect to it. We don't want to burn the firmware because we just want to go, it's still on the file system, it's still there. So the problem is we don't get, we don't get to the chip anymore. So what can we do? What can we do? We can use here Putty to get to the chip. So let's do that. This is if we start Putty, and we want to connect via serial line, and we want to connect to COM4, and this is 115/200 as speed. So if we connect now, we are seeing what it's printed out, and I can see it's still working. And so the AutoRun worked. We came up here, and I can now press Ctrl+C to stop it. So if I now plug it in, plug it out and plug it in again, I would be in the same program, and I can do that. If I plug it out, I lose the connection here. So Putty will lose the connection. Okay, so error reading the serial port, and with this I can close it. But what I can do now, I can plug it in again, and the program starts running, but I still have the problem that I cannot connect here. If I try to connect, it says cannot connect, but it says this in the way, do you want to burn the firmware? So we don't. We start Putty again. It is still COM4, and the speed is 115/200. And let's connect. So here we are. And now I do Ctrl+C. Now I can use the operating system, which is on there, to see what files are on there. For this, I import uOS, and this is like in Python OS, but the U stands for micro. And now I can say uOS list dir, and with list dir, I can see there is the boot on there, there is the display library on there, and there is main.py. So what I can do now, I just delete main.py, and I do this by uos.remove, and I put in quotation marks main.py. And if I do that, and I list again, so it's not there anymore. Now if I reboot it, I unplug it, so Putty again loses the serial connection, that's fine. If I plug it in again, there is no main anymore, and it boots nicely. So, but it doesn't go into our software. So, but I can now connect again with the serial line. And here we see on the device, our file is missing the file which I earlier put over. So I put this file over, and now I could rename this and I can work again. So to remember, if you have your main.py on there and you want to stop it and want to use the uPyCraft IDE, you have to use Putty, delete your main, go back and do it again. So this is sort of how it works. We have a main file, and if we use Putty or other tools, it's quite easy. With the uPyCraft, we have to go through this loop, and first use Putty to stop what the program that's on, delete the main file, reboot it, and then we can connect again. Now there is one question left. how do we do it if we have multiple programs? So renaming our file in main.py is not a good idea. So what we usually do is we create a main file that calls what we want to do. So for this, I delete this again, and we have a quick look what I do. So instead of having this as a program we call, I have now changed this into a function, and I do this just to show how to do that, how to change this. So how do we do this? So what we do is all the code that's executed we put into a function. How do functions look like? Function definitions in MicroPython. And they look the same as in Python. So what we do is we have def, we have the function name, we may have parameters, then we have a documentation string, then we have the function, and then we do return. So let's change our code in order to make it like this. So let's do that. Def, and we call it my main, and I don't give any parameters. Now it's important, the function definition ends with a colon. And now what we do is in the next line we have the documentation string, and I write something what the function does, that reads analog and prints to display. So, and now for all the other lines we just have to indent them so that Python knows it's part of the function. And if you have a nice editor, you can do this by just marking everything and indenting it. Here I just go through all of them. And now I have done this, and now I can save it as ADC to display function, and I do that. And I did it before, so I replace it here. So now we have a new one which we can call. So let's put this onto the chip. Okay, so what we can do now, we can import this. Import ADC to disp F, and now we can call our my main function. So that's the function we did. And I have a syntax error, it says. So let's have a quick look what's in there. So it seems not to work, and it says, so we have my main, which I have here, and let's see why this is not working. So the import still works, and now if I do my main, this should be what I have here, and let's try again. So this is strange that it doesn't work. So we have to now look. So what I usually do if it doesn't work, I first check if everything has been really loaded to the chip. So what I do is I unplug the chip, I plug it in again over serial line, I reconnect, and now I check. So this is here, this is here, this is here. So let's try again. So hopefully there is nothing in there that shouldn't be there. So Let's try again. And now we try it again. And now it works. So sometimes before you can access it, it didn't download it very much. So the uPyCraft IDE is very good to get started, but once you go into serious development, it makes sense to look at one of the other IDEs like Microsoft Code or another IDE where you can include it. So, but what we see here, it is working. And I stop this here. And so basically these two calls, what we have here, and I stop it here. So import, that's what we put in our main file. So we create a main file which we put on, where we put those two things in. And I've got one here, and I show it. So this is basically what we have in here. So I save this as main here. So, and then I put it over. So we have now a main file. And the only thing the main file does, it imports our module and it executes this. So later, if we delete something, we only delete the main file. And so let's try again. So what should happen now? Let's unplug it and plug it in. So what we see now, it starts running, but we have the same effect as before. If I try to connect to COM4, it doesn't work because the program is running, it can't connect it with the PyIDE. But what I can do, I can, as I did earlier, I can use Putty. I go to COM4, speed is still 15200. I connect. Oh, it was I didn't click on serial. So I click on serial and it's COM4 115200. And here we are. And there's something wrong here. Let's try again. So serial line COM4 115200. If you get garbage, it may be that you have mistyped the speed. And what we see here, it's working now. So what we see now, and now if we can reboot it here, and what we see, it starts into, and what I can do now here, I can break it, and I can say import UOS and UOS dot remove main.py. And with this, if I restart it now again, it doesn't start our program because the main is not there anymore. And if I'm now closing this one, I can connect again here. And what we see, I deleted main, but this one is still here. Now there is one more thing to think of. So what we did now is we replaced main, and always when it starts, it goes into our program. And it was quite sort of awkward to go back to Putty, to stop it, and then to open it again. So what we usually do, we would write a main program, and that's typically the same for all we do. We use one pin where we can decide whether or not it should always boot into it, or whether it should boot into it, or whether it should not boot into it. And for this, what we do is we use one pin and check. So let's build this piece of software up. So I use this main here. I open it with an external editor, as we saw. It doesn't really work too well. So what I do is I also import the function for the pins. So from machine import pin, so that I can use the pin, that I can read in a pin. And so what I do now is I define, and I use, if I look here, I use pin 26. So P26 is pin, and I use the pin 26, and I use it as an input. So now I can read pin 26, and we can have a quick look to remind ourselves how this works. And there is the quick reference, and we are using the ESP32. And here what we see is we have imported pin from machine. We have defined an import pin. In our case, it's pin 26. And we can now, with the variable .value, we can access it. So what we do now is we do if, and now we access the pin. So basically, if this is 1, we execute this. How do we get this to 1? It is 1 if it's connected to 3.3 volts. It's 0 if it's connected to ground. So let's save this, and we put this onto the device. So now if we start, it goes into this software. So I have now 2 cables, a red one and a black one, and I connect the black one to ground, and I connect the red one to 3.3 volts on this side. And now what I said, okay, and what we see here, this is a bit inconvenient again with the ID. It doesn't update it here, even so we copied it on. And if we restart it now, it would update here what's on there, but we can still have a look. I close it here, so we still can have a look what we put on. Let's open it with the other editor. So what we have here, if it's equal to 1, it should boot into our thing. So let me connect the 1 to 26. Okay, now let's see. I reboot it now, and I reboot it by pressing this button. So it may not have worked. So let's put this on here. It seems it didn't work. So I close this here, and let's see what happens. So, and I connect it here, disconnect and connect. So it's not starting. So let's see with Putty why it's not starting. So I still have COM4 here, and I can just open it with this one. And so let's reboot and see what happens. So it says there is a syntax error in line 8. So perhaps there is something here. And here it's very easy to see I forgot the colon. So let's save this. So I forgot to put this colon in, that's why it's not working. So I disconnect, and what you see with Putty, it's very easy to just go on there, and then you can reboot and you see where it goes wrong. Now we still don't have the software on the chip, so what I do, I use the uPyCraft IDE to put it on the chip. So let's put it in there, COM4, and I put it on here. Okay, and it worked. So we have it now on there, and we should see it here. It's with the column. Now what happens is I reboot, and I have now connected the red cable, so 3.3 volts. So we should get equal is 1, so it should start. Let's do that. And now we see it's running. And if I unplug it and plug it in again, so we do that. I unplug it, I plug it in again. Now what we see, our software is working, and now we are again at this point that I cannot connect because the program is running. Okay, so I can't list, but what I can do now, instead of the red cable which connects to 3.3 volt, I connect the black cable. And if I now unplug it and I plug it in again, we see the program is not starting, and we can use now again this IDE to connect, and now we are here. And so this is quite useful, and I would recommend to use this main file where you basically just exchange the software you write, what you wrote, and what you call, but that you dedicate one pin for whether you want to start it or you don't want to start it. And you can use the switch that's provided in the box to make a boot selector, whether you want to boot into the development mode or you want to boot into the real thing. And I just lost the camera here. It's coming back. So let's quickly show you the switch. So I have the switch here. This is this component. It has 3 cables. And so what you do is the middle one goes here. I take them both out. So the middle one goes to pin 26. One goes to 5 volts, to 3.3 volts. One goes to 0 volt. And now you can, with this switch, select whether it boots into it, and we can try this. Let's do it this way. So I connect now the power bank, and I have it now to 0 volt. And so what we do, if I connect it here, we see it's not booting into the code. I unplug it and I switch it to 5 volt, to 3.3 volt. And when we boot, it goes in here. And I can switch the switch while it's running. It doesn't do anything. It's only the selector at a time. And as I said, if I now unplug it and plug it in again, it's not starting it. If I switch it to the other side and I restart, it's going into my code. And I think this is really nice. Oops. So let's try again. So this is really nice. So your cable, your switch is soldered. This one is not soldered, so I take this out. So this is a good way of having an easy way. And you could now think of a little more how to advance this. Instead of asking a local pin, you could make an internet connection and ask, does the user still have the license? And if yes, I boot into it. If no, I don't boot into it. I just show a message, you don't have a license anymore. Things like this. So basically this boot selector in this main makes a lot of sense. You can do a lot of things like looking at local pins. You could have a switch which selects between different programs. You could have a sensor that selects between different programs. So in this main function, you can decide what happens during the boot process. And we will look at some point how you can use the network variables to decide which program should be run it. And I think with this, you should know now how to write a program to make it into a module which you can call, and then have a main function on the chip that's calling it. So the boot, the way it's booting it, it calls first the internal stuff, then it calls boot.py, and after boot.py it calls main, and you should put your code which is called somewhere else and call it from the main function. And with this we're good here.